Welcome you all to this video lecture. So in this video lecture, we will be discussing about the Dag representations of basic blocks. So what is Dag? So Dag for a basic block is a directed acyclic graph with the following labels on the nodes. So here, the leaf of the graphs are labeled by the unique identifiers, and that identifiers can be a variable or name, or it can be a constant. Variable name or it can be a constant. So all your interior nodes will be a operator symbols. So nodes are also given a sequence of identifiers for labels to store the computed values. Right? So whatever the values that is being computed, which will be stored in the labels, we'll see to that. DAGs are the type of data structure which is used to implement transformations of basic blocks. So DAG provides a very good way to determine the common sub-expression. So in the next set of videos, we will be discussing about the common sub-expression. And it gives a picture representation of how the values are computed by the statements used in a subsequent statements. So for example, if one expression is being given, so this DAG will say how those each and every step of evaluation with the results will be easily been identified with a pictorial representation. And here we'll have three examples. First, here we'll try to construct a graph DAG for this. A equal to A into B minus C plus B minus C star D. Right? So we'll start from, see, when we consider this expression, which one will be executed first? This, whatever that is inside the parenthesis will be executed first, right? So here B minus C will be executed first, right? So now here, right from here I am constructing, so minus B C. Your left child will be B and your right child will be C. Do we have any other expression to be evaluated in parentheses? Yes, we have. That is B minus C, which has been already computed. So leave it. Next one, what we will do? We will do A into B minus C. So you place this operator into. So what is the left child? It will be A. Right? And then what will be your right child? It will be the minus of B plus C. This entire part will be coming here. Right? Then after that, what we need to do? Now you go for the second part. Okay, so that is B minus C into D. So here you put the star, your left child will be B minus C and your right child will be D. After that, so here this is the recently computed value of A, B, C and D. Okay, then you have to add these two things. Okay, just put plus. So with the plus, this entire statement will be the left child and this entire statement will be the right child. So this particular part is over, right? Next, this entire statement need to be added with this A, right? So put plus here. Which is the recently computed value of A? This one. So no need to include another A here, just map it with this A. This will be a left child and this one will be your entire thing will be a right child. Clear? Now we'll see another one example also. A equal to B plus C. Okay, just please watch it very carefully. A equal to B plus C. What we will do is that plus, first we'll put plus B C. What is the value? This is what we have mentioned it as a label, right, in the previous slide, right? So A, and after that what we need to do? A minus D, which is the recent computed value of A, this one. Okay, so minus, put minus here, and of your left child will be A and your right child will be D. The result will be stored in B, so add a B here. Done. Next one, what we need to do? B plus C. So add plus here. So here minus is over, right? So then we'll add B, and what we need to do? We need to add B and C. Here also we have a B, but which is the recently computed value? This one. Okay, right? So B plus C. Okay, so plus, what is C here? This is the recently computed value of C. So put this here. So plus, your left child will be what? B. This is the recently computed, connect to it. Which is the recently computed value of C? This one. So connect to this. That's it. Next one, what we have? A minus D. We have already computed A minus D at this part, right? At this part, we have already computed A minus D. Just add a label D here. That's it. Very simple, right? Here, we'll take one more example. What is here? A equal to B plus C. So first we will do with B plus C. So plus B, C, mark a label as A. What is next one we have? B minus D. So minus we will put here. which is the recently computed value of b, this one. So add this. On your right shell, what you will have? You will have d. Just add this. Okay. Next one, what we have? C plus d. So do we have computed c before? Yes. So this is where we have taken the value of c. So put plus here. Okay. Then left child will be c, which is the recently computed value of d, this one. Just map this. That's it. Okay. So both c plus d value will be again stored in c. So in nearby this plus, you add c here. What is the next statement? We have b plus c, which is the recently computed value of b, this one, not this. This one will be the recently computed value of b. So your left child will be b, which is the recently computed value of c, this one. Okay, so put plus, left child will be this b and right child will be this c. That's it, right? Fine. Here is another one example that we have. This is very simple. So b star minus c plus b star minus c. Which will be computed first? Unary minus. So minus c. So right from here, minus, it is an unary minus. So you will be having only one child, that will be a right child. Add to it. Next one. After this, what we need to do? B into that minus c. So put star here. Your left child will be b and a right child will be this entire c. After that, what we need to do? Here also we have the same expression, right? B star. This is been repeated here, right? In the second part, b star minus c. Very simple. We need to add it. So plus, who will be the left child? This b star minus c. Who will be the right child? The same b star minus c. That is why this particular connection we have done. After that, what we need to do? We need to store this back to a. So equal to a. Okay. And this is something this you can have, and let me do one thing. I'll go with this, right? So here, this is the 3 address code. For this 3 address code, we are supposed to construct the DAG for it. Very simple, right? We'll start with the first statement. What we have in the first statement? 4 into I. So star 4 I naught, we will be storing in S1. Done. Next one, what we have? A of S1. So this operator will be of, okay. And here we know what is S1. This has been computed. Just add it. S1 is nothing but 4 star E. So then what we need to do? This one, this array operator. So inside that will be your right child. A will be your left child. Just do that. This is the array operator. Left child is A, right child is S1. Now we have it. Now we have a separate thing for S3, right? Listen here, 4 star I we have already computed, right? So what we can do is that instead of again constructing one small DAG over there, just put S1 comma S3. That's it. That is what we have done here. What is the next step? S4 is equal to B of S3. And next one. This is what we have done here also. Next one. See here, this we have done. S1 comma S3 is over, right? So here, that is what I have given here. 4 star I naught node already exists. Hence, attach the identifier S3 to the existing node statement. Right. Next step, what we need to do? Here, S4 is equal to B of S3. So S3 is nothing but this one. Okay. So what we will do? Do we have computed B before? No. So then add this array operator. Then onto your left child, you please add B. Onto your right child, the same thing will be coming 4 star I. Done. Next one. What is the next statement we have? S2, S4. We have already computed S2 and S4. We have to simply do the multiplication of it. So combine this, put a star here and combine these two statements, S2, S4. Label this as S5. What is the next one we need to do? Prod plus S5, production plus 5. So add one plus here. Add one plus here. Your left child will be product 0 and your right child will be this entire 3. This entire 3 will be on your right hand side. Okay. So plus S6. Okay. Hold on. What is the next statement? Product equal to S6. So this is what we have computed before. So just assigning to it. So just put comma pro. Okay. The next one we have S7 is equal to I plus 1. This is what? S7 is equal to I plus 1. See, listen here. S7 is equal to I we have already computed. This is the latest value of I here. Plus 1 we need to add. Okay, then we need to assign I is equal to S7. Okay, see. Here we have computed I0. So what we need to do? We need to add that S7 is equal to I plus 1. So plus I on your left On your right it will be S. So just make it as S7 here. I equal to I plus 1, right? And then here we need to assign this S7 back to I. So that is why we have given comma I here. Okay. Then at last what we are supposed to do, if this I is less than 20, then go to 1. So what we have in 1 is 1. Okay. Now you see the DAG. So this will be a final DAG. Less than or equal to what? Which one is less than or equal to? Here, that is I less than. I is then S7. That is in this particular, the last one which we have constructed. So I, what is that operator? I less than 20, right? So here less than, this side we have I. On your right side we have the constant 20. Just add this. This will be a, so no need to give this connection to the first one and all. That is not needed. This is not a flow graph. This is a DAG. How the statements, how the internal expressions will be evaluated. So this is the final DAG for the given 3 address code. So this is how we will be constructing the directed acyclic graph for the given 3 address statement or for the given 3 address expression. Thank you.